In this video, we are going to be talking about the average value of a function. So in single variable calculus, we were able to find that the average value of a function actually had a particular formula. So in single variable, okay, so the average value, so I'm going to write f average is equal to 1 over b minus a, integral from a to b f of x dx. So you may or may not have remembered this. And if you don't, it's okay. Basically what this is that if I had a function, so let's say this is my function, f of x, and then this was going from a to b, I wanted to figure out what basically the average is, or the mean of this particular function. So where exactly is the middle? If I were to add all of these individual rectangles and I added them and divided it by the total number of rectangles, then I should get maybe an average value. So maybe my average value is right there. So maybe here's the average value. So that's basically what you do in single variable calculus. Now in multivariable calculus, we also can extend this. So multivariable, we can actually extend this. That looks like an ugly multivariable. Okay, so in multivariable, we still also have a formula. And here's the formula. So I'm still going to write f average is going to be equal to 1 over, now in this case, it's going to be the area of the region R, double integral over the region R, f of x comma y, dx dy. Now, obviously, because iterated integrals, you can always switch the integration however you'd like. So this formula is really self-explanatory. So basically, what is this area of R? Think about it like, so remember the area is going to be whatever is in the xy plane. So if it's a rectangle, it'll be really easy to figure out what this area is. It's just length times width. If it's a triangle, then it'll be 1/2 base times height. In the majority of the parts, the majority of the time, it's always going to be a rectangle. So it'll be really easy to figure out this area. All we really have to figure out is this double integral, which we just did in the previous video. So if you still need a little bit more help with double integrals, you can just watch the other video. Okay. So here I have a word problem. Okay, so somewhere where you might be wondering, where exactly am I using double integrals in my life? Here is an environmental science problem. So here, take a moment to take a picture of it or write it down on your notes. So here what we want is that the air pollution near a chemical refinery is given by the function f of x comma y is equal to 20 plus 6x squared y parts per million, and we call it ppm. So where x and y are the number of miles east and north of the refinery. So find the average pollution level for the region R shown below. Okay. So just when you read this problem, you might be wondering, okay, what exactly is going on? So what really is going on is that you have this function. Someone has modeled this function. Or model the pollution using this particular function, f of x comma y. So this is how we're modeling it. So we can kind of quantify the air pollution given some number of miles east and north. So for example, let's say the chemical refinery is right here. If I go 1 mile east and then 1 mile north, I'm going to have this little square. I can calculate what that particular pollution is going to be there. But in this case, this problem is not asking that. This problem is asking for, if I were to go 2 miles east and 3 miles north, what would be the average pollution in this area? Okay, which is actually really a really good question, because in terms of air pollution, you don't want it to be, you don't want your company or whatever to make it be or mess up the environment. Okay, so what we really want to figure out is what is the average pollution level. So we know how to calculate that. Someone gave us, was able to model it, okay? And now we just need to apply it using this formula. So we know that the average, okay, f average is going to be equal to 1 over the area of R, of the region R, double integral over the region R, f of x comma y, dx dy. Okay? So the first thing to do is we need to do two different things. So the first thing is that we need to find area of R. Okay, find the area of the region. Okay, now what kind of shape is this area? Well, this is just it's a square. We can find the area of the square. That's just going to be the area of this R is going to be equal to the length times the width. In this case, the length is 3. It will be 3 times 2. Okay, you can interchange them. You can say 2 times 3 if you want. So the area of this R is just going to be 6. Okay, that's it. Okay, that's the area of the region. Okay, so that's the first thing. So we kind of already figured out what this guy is. Now we need to figure out what this guy is. So the second thing is find the double integral. Okay, so find this double integral. Okay, so we have the double integral over the region R, f of x comma y, dx dy. Okay, now if you just want to follow this x and y, well, you can do it, or you can just flip them. So in this case, the limits of integration with respect to x is going to be what? It's going to be from 0 to 2, because that's how far x goes. Here's x. Okay, it's going to be from 0 to 2. And the limits of integration from y, well, here's the y value. Here's the y. It's going to be from 0 to 3. Okay. F of x comma y, that's given to us. It's going to be this 20 plus 6x squared y. And then the first is going to be dx. The second one's going to be dy. All right. Now what we're going to do is let's evaluate this double integral. So I'm going to leave the 0 to 3 by itself, dy. And let me just go ahead and evaluate the inside of the integral. Okay, the integral is going to be with respect to x. So the antiderivative of 20 is going to be 20x. And then the antiderivative of this is going to be 6x cubed y over 3. It's going to be from 0 to 2. Okay, so this is going to give me the integral from 0 to 3, 20x plus 2x cubed y. Okay, this is going to be from 0 to 2 dy. Okay, now we're going to use the fundamental theorem of calculus. So from 0 to 3, 20 times 2 plus 2 times 2 to the third power y. Okay, so this is the first part. Then minus 0, because if I plug in the 0 in there, it's just going to go away. dy. Okay, and I'm plugging it just to the x's. So this is going to be from 0 to 3, 40. 2 cubed is going to give me 8. 8 times 2 is going to give me 16. Y dy. So now notice I only have one variable, y, and I'm good. All right, now all we got to do is take the antiderivative of this. So I'm going to have 40y plus 16y squared over 2 from 0 to 3. So that's going to give me 40y plus 8y squared from 0 to 3. Now we're just going to plug them in. 40 times 3 plus 8 times 3 squared minus 0. And what we're going to get is 192. Okay, so now what did we do? So we did two different things. So we found the area of the region R, and now we found the double integral. Okay, now there's a third step because that's not the answer. Okay, because we still got the third step. The third step is plugging it in because we wanted to figure out the average value. Okay, so f average is equal to 1 over the area. The area was equal to what? 6 times the double integral. The double integral in this case is 192. So if I take this, and I put this in my calculator, I'm going to get 32. And this is going to be parts per million. Okay, so this is the average amount of air pollution, right? Of pollution level for this particular region. So if I were to go 2 units or 2 miles east and 3 miles north, the average pollution of this entire region is going to be 32 parts per million. Okay,